Hey everybody, welcome to your first video of Unit 3. This unit covers all about matter and its changes. So in science, matter matters. We're dealing with atoms and particles and solutions. Those are all different types of matter. So let's go ahead and get into it. Here's a nice little flow chart that's going to help you decide which classification of matter something is. This is a good thing to memorize. Print out a blank one and try to fill it in as you go, because if you can't fill this in, you're not going to be able to distinguish between the four types. You see those four little boxes down there at the bottom. But first, let's talk about what matter really is. And its definition is anything that has mass and takes up space, which means volume. So if it has a mass, if you can weigh it, and it takes up any type of space, if it has any kind of volume, it's considered matter. So when you're given a piece of matter or a solution or something, you got to look at it, and you got to ask yourself if it can be physically separated. So can you take your fingers or tweezers or some really small laser beam and separate it physically? If you can, oops, wrong way. If you can, it's called a mixture. And we'll talk about those filtration and separation lab techniques when you come into lab. We'll show you what they look like. But those are two easy techniques. You'll get a better idea of what it means to be physically separated versus chemically separated. If you cannot physically separate it, it's called a pure substance. And now we're going to talk about, for the rest of the time, the difference between mixtures and pure substances. So let's focus on the mixtures first. Once you decide that it cannot be physically separated, you have to look at it and see if it looks the same throughout the entire piece of matter that you're dealing with. If it does look the same, if it has that uniform composition, it's called homogeneous mixture. Those would be things like sodas and salt waters, things like that. If it does not look the same, if it does not have that uniform composition, it's called a heterogeneous mixture. Then we have this little picture up here, the little glass of water on the right there. That has a uniform composition. It looks the same from top to bottom, from left to right. So that's a homogeneous mixture. So we call that one homogeneous. The one on the left, you can see that's got little speckles in it. And you can see that laser beam, that beam of light come through here. So we can tell it's got different things in it, so that's going to be a heterogeneous mixture. This is actually something called the Tyndall effect. I'll write up here, you might see it in class. Tyndall effect is in heterogeneous mixtures, light will be scattered and dispersed. And you can see that you can see that light beam going through the water, you can't even see it. Then you get to that little whitish piece and you can see the beam go right through the water. So the other side is pure substances. So when you're dealing with pure substances, you really need to look at the chemical composition. So let's look at the chemical makeup. Okay. Then you got to ask yourself, is it made of only one type of atom on the periodic table? If it's not made of one type of atom, it's called a compound. So take something like H2O. H2O has hydrogens and oxygens in it. So we have two different types of atoms there. So if it's got more than one type of atom, it's called a compound. If it's only made up of one type of element, it's called an element, obviously. So here we can have O2, or we can have iron, or carbon. Those are all simply elements. Those are the easiest ones to find and identify. So let's keep going with our separation. Let's talk about pure substances. We already know we got two types of pure substances. Once again, they're uniform, they are unchanging. Every sample has exactly the same characteristics and properties. And every sample normally has the same balance between elements. So every compound of iron 2 oxide, iron 3 oxide, is going to have Fe2O3 in the same ratio. So you know you have your two types, your elements. You can see that this looks the same throughout. It's got the uniform composition. The elements are silver. If it's found on the periodic table by itself, it is an element. Elements cannot be separated. It cannot be separated into simpler substance by physical or chemical means. Now you might be saying, well, can't we split atoms? The answer is yes, but that's not a chemical means of separation. That's actually a nuclear means of separation, and we'll talk about that towards the end of the year. Now, compounds, once again, they have different numbers of elements. We have sodiums, we have hydrogens, carbons, and oxygens, all in this sodium bicarbonate. That's baking soda. So compounds have more than one element in the periodic table. Let me get this out of the way so you can write that down. They have combinations of 2 or more elements that are chemically bonded. And here's the thing, a chemical change is required to combine elements into compounds or to separate the elements. So to review, elements, single elements, you can find them on the periodic table. If it's not just one little box in that periodic table, it cannot be an element. Compounds have several elements combined together to form one single compound. Elements cannot be separated in simple substances. Compounds take a chemical change or a chemical reaction to change those bonds up. Now mixtures. Remember, we've got 2 different types of mixtures. Heterogeneous mixtures are not uniform throughout. They are made of very large molecules, so you take a look at the dirt. You can see different colors of different things inside that dirt. You can see the brown dirt itself, little white pieces of fertilizer, little brown pieces of whatever is in there. But you can actually filter those out, so it's a heterogeneous mixture. It does not look the same. Homogeneous mixtures, on the other hand, look the same throughout. They have a uniform composition, and the key thing here is that they are also called solutions. Homogeneous mixtures are called solutions. Keep in mind that mixtures versus compounds, mixtures have several different compounds making them up. So this soda, for example, it looks the same throughout it, from top to bottom, from left to right, but it's still got sugars, it's got gas in it, it's got flavors, it's got food colorings, all form one mixture. So I hope you see the difference between the mixtures and the compounds. And you can have different kind of mixtures. It doesn't just have to be liquid mixtures. This is just kind of extra. You really don't need to write this down in your notes. But if you have gas to liquid mixtures, that would be soda. Gas to gas, that's your air. I just want to throw it out there that air is a homogeneous mixture. Something that will come up a lot. It's got nitrogen, oxygen, all those other things in there. Water's floating around in there, but you can see through air. So it's the same from the top of the room to the bottom of the room. So it's a mixture. Liquid to liquid are the most obvious kinds that you see most commonly, like gasoline, alcohol, vinegar. All those are liquid to liquids. Then solid to solids, those are alloys. Those are mixtures of different metals. They don't actually chemically react, but they are still mixed together. So those are weird. This next slide will show you what those alloys look like. So these are alloys. Now you girls or you guys that like your bling, you got 24 karat gold, which is pure gold. So you take a very powerful microscope and you look at those individual atoms and you see that it's nothing but gold there. So this is actually an element, because it's nothing but pure gold. Now the 14 karat gold is an alloy of gold and silver. So if you take that same microscope and look at this 14 karat ring, you can see that it's got different molecules in it. But they're not really chemically bonded together. They're just kind of floating around together. So that's what we mean by alloy. And you can see down here another just chart about homogeneous versus heterogeneous. Not a big deal, kind of extra. So here's your example. Go ahead and pause it. Try these on your own, and we'll come back and check. All right, let's see how we did. Soda. Remember we talked about this one in pretty great detail. It's a mixture of sugars and dyes and waters and gases. But it looks the same from top to bottom, from left to right. So we know it's a mixture, and we know it's homogeneous because it looks the same. Now rust may have been a hard one for you, because we haven't talked that rust like this, like I spoke about earlier. Rust is iron trioxide, Fe2O3. That's what rust is. If you knew that, great. If not, now you know. So we see it's got both iron elements and oxygen particles. So it can't be simply an element. It's definitely not a mixture. So the only thing left is that it's a compound. Iced tea is kind of tricky. Tea on itself is a homogeneous mixture. But when you throw the ice part in there, now it's different at the top. The ice floats at the top, the tea's at the bottom, and now it's mixing together, but you can see that there's ice on top and tea on the bottom, which means it's got a different composition throughout, which means it's heterogeneous mixture. That one could have been tricky. Chicken soup, that one's easy. It's got soup, it's got noodles, it's got chicken. That's heterogeneous. It's easy. You can physically separate all those things out. Dirt's been our example the whole time. You can pick little things out of the dirt, so it's heterogeneous. Chlorine, if you have your periodic table, remember I have a periodic table on my website. Chlorine is on the periodic table by itself, so it's an element. Sugar, if you remember from your biology, is C6H12O6. We always talk about glucose when we're talking about sugar. So since it's got carbons and hydrogens and oxygens all in the same ratio, that's got to be a compound. Now gasoline, I hope you know about gasoline. It's got all kinds of, it's got hundreds of chemicals in it. It all looks the same. So it should actually be homogeneous. Right, gasoline, it's got hundreds of different chemicals making up one solution. If you've ever seen gasoline, it does look the same from top to bottom. Nothing separating in it. It's all one big solution. If it's a solution, it's a homogeneous mixture. Now water, a lot of people try to think water is an element because it's an element of the world like fire, but it's not. We talked about this earlier. Water is H2O. It's got hydrogens, it's got oxygens, all combined together, so that's going to be a compound. Now you will get a lot of practice with this. So if you're struggling with it, please keep practicing with it. It'll start to click, I promise you. And that's all for this one.